Welcome to today's video where I'm going to discuss how to differentiate the trigonometric functions. I'm going to show you, I'm going to use sine as my example, and then we'll just kind of jump right to the rules. It's essentially a chart of rules that you're going to need to memorize that go along with each trig function and its corresponding derivative. Okay, so just some background here. It talks about how don't lose sight of the fact that f prime of x derivatives represent slopes of tangents. So if you look below, I've got a graph here of sine of x. And there's a series of purple tangents drawn. And if we used just kind of an estimation technique and said, well, right here, clearly the slope of a tangent, so m would equal 0. Over here, m would equal 0. Down here, m would equal 0, and here, slope would also equal 0. Well, of course, m can be interchanged with f prime, so it tells me that the derivative of sine x at 90, or in radians, pi over 2, the derivative is 0. The derivative at 3 pi over 2 is also 0. Negative pi over 2, 0. If this graph below would represent the graph of the derivative, so basically at 90, f prime is 0. So I go down to my f prime graph and I say, well, f prime is 0 at that point. Then I say, all right, at 3 pi over 2, f prime would also be 0. At negative pi over 2, f prime would also be 0. And then again at negative 3 pi over 2, f prime would also be 0. Here at 0, if I was to estimate the slope of that tangent, well, it looks pretty much like a line that's going through your ordered pairs 1, 1, 2, 2, 3, 3. It looks like a line that has slope, or f prime, equal to 1. Therefore, at 0, it looks like the slope is 1. So that's why there'd be a dot up here at 1. Here, it looks like this line has slope negative 1, which would mean my derivative should be at negative 1 at that angle. At this angle, it appears the derivative is negative 1 again. If we did it again over here, it appears that the derivative is positive 1. Now, just using those, it kind of looks like these dots fell perfectly onto this graph. So this was the graph of y equals sine x. Well, you may recall, or hopefully you recall from your studies in pre-calc 12a, that this is the graph of y equals cos x. So it looks like if you have f of x equal to sine of x, it appears that f prime of x is actually cosine of x. Now we're going to look at that algebraically and see if we can prove it in a more concrete manner than just kind of looking at the graphs of them. And then if we go back to our definition of a derivative, so f of x is sine x, which would mean f of x plus h would be sine of x plus h. And the definition of a derivative is here, which we started, that's the first way we found derivatives. So there's f at x plus h, subtract f at x all over h. This is one of your trigonometric identities I gave you way back when we started talking about just some calculus concepts that you'd need to make sure you knew your trig identities. That's called an expansion identity, so that is replacing that with a trig identity. Other than that, nothing else changed. We shuffled things around a little bit here. We grouped together this term and this term over h, and then we took this one and just separated it. Again, nothing too exciting other than just kind of regrouping things. You'll see why here in a second. What that did is it generated a GCF within this term of sine x, and then this bracket turns out to be what is a limit identity that we haven't really studied this limit identity. We did this one over here where you take out your sine h over h as h goes to 0. So that is one we did. This is another one that I'll just identify it down here. Again, we didn't use it, but this is always true. Just like this one was true. Not really sure why we didn't do this one, but we could have just as easily done both of them. We only did the one just to show you. I guess I wanted you to see how these identities work, but we could have easily set up this one as well. This expression is equal to 0, this expression is equal to 1. So if I go up here, this expression is equal to 0. If I do the limit of this as h goes to 0, and this one is equal to 1. Well, if I substitute a 1 for this and a 0 for this, let's see where that would take us. Down to the next one. Sine x would stay there. This we said is equal to 0. Cos x, I leave that as cos x for now as h goes to 0, because h going to 0 has no impact on the variable x. H is going to 0, not x. This bracket, or this expression, would become a 1. Well, if anything times 0 is 0, so this basically disappears. And as we thought was the case, the derivative, f prime of x, does in fact turn out to be cosine of x. So if you have f of x is equal to sine of x, f prime of x is equal to cosine of x. Now all of your 6 trig ratios, through some form of algebraic manipulation and using your definition, you could develop what are called the rules to differentiate your 6 trig functions. Now I'm not going to go through all 6. I'm just going to give you those right here. Oops. So this chart, you're probably going to want to pause the video here and make sure you get these written down. Then I'll show you how they work. So it's saying that u here, this u, is representative of some differentiable function. So it's not like it's not a number. This would mean, for example, just to show you what it means, if I had y equals sine of x cubed, well the u would be x cubed, and the rule works this way. It's sine of u, and then you differentiate the argument of your trig ratio. So this is your du. This is what du stands for, 3x squared. So it's in a way it kind of models the chain rule that we looked at in our differentiation rules. All right, the derivative of cosine u is negative sine of u multiplied by the derivative of whatever u is. The derivative of tangent of u is secant squared of whatever u is multiplied by the derivative of u. The derivative of cosecant of u is negative cosecant of u cotangent u du. The derivative of secant u is secant u multiplied by the tangent of u multiplied by the derivative of u. And the derivative of cotangent u is negative cosecant squared u multiplied by du. This set of rules needs to be written down and eventually memorized. Now for the rest of the questions that we do today, you'll probably want to have these sitting on a page nearby so you can refer to them. Obviously you're not going to have them memorized off the top of your head already, but you do need to know these. So as I said, maybe pause, get those copied down, and then I'm going to show you how these rules work. I want to point out one thing here before or while you're writing them down. If you notice that there are 3 of them, this one, and this one, that are negative, so that all the rest of them are positives when you do your derivative rules. However, these 3 are negative. There is one similarity that I can show you, that all of the rules, or all of the trig functions that have negative derivatives, coincidentally also start with the letter c. So the derivative of cosecant is negative whatever. The derivative of cosine is negative. The derivative of cotangent is negative. So that might be a way to at least keep track of which ones are negative. The ones that are negative start with the letter c. Now, how do these rules work? Well, first thing I need to remind you is that all the rules that you were shown before do not disappear. You still need to know your power rule, your product rule, your quotient rule, your chain rule. I don't know which one I forgot, but it seems to me I forgot one of them. Power, product, quotient, chain, 4 of them. Okay, so for example, let's just start out with some basic ones. Let's suppose I had the function f of x is equal to the tangent of 7x to the 4th minus 2x. This would be the u. So the u is what we refer to as the argument of the trig ratio. According to this rule, the pattern then for the derivative is secant squared of u. Remember, this is u. So it's secant squared of u. And then I multiply that by the derivative of this expression, which would be 28x to the third minus 2. So secant squared u multiplied by du is the derivative of tangent u. All right. A couple more just before I have some pre-made, but I just wanted to look at a couple so you can see how the rule works. So let's say I had y equals cosecant of radical x. So y prime would be, starts with the letter c, so I know it's negative. The derivative of cosecant u, according to our table of rules, is negative cosecant of u, cotangent of u, multiplied by the derivative of u. Now, what I was saying earlier about our other rules, they still exist. So suppose we have the square root of 1 minus secant x cubed, and we're going to divide that by cotangent to the fourth of 5x to the fourth. Now we've seen this notation before, but this really means the cotangent of 5x to the fourth, all in brackets, to the fourth power. So that's going to have to be treated as a chain rule when we arrive at it. So if I look at this, I would say, well, I'm dealing with a quotient rule. Quotient rule says to take the derivative of the numerator. Well, the numerator is something underneath a radical, so that's a chain rule. This is all in brackets to the 1/2. So the chain rule would say 1/2, 1 minus secant x cubed to the negative at half. Then I need to multiply by the derivative of what's in the bracket. So it's 1 subtract this, so my derivative is going to be negative. That negative is there because of that, not because of the rule. I know the rule for secant is not negative. Secant is secant u, secant of u, tangent of u, multiplied by du, derivative of the numerator. Multiply that by the denominator. I'll color code it here so we can follow. Subtract the numerator. I'm running out of room, so I'm going to jump down below here. Now I need to multiply that by the derivative of the denominator. So as I've mentioned, this means this. So I have to treat it as such and use the chain rule. 4 cotangent of 5x to the fourth. Ugh, it's a bad 4. Try that again. Cotangent 5x to the fourth. That's my argument, so I'll put it in brackets. That would then be to the 3. Now I need the derivative of what's inside the bracket. So inside the bracket I have cotangent of u. Derivative is negative cosecant squared of u multiplied by du. This is where brackets get a little confusing here. We got to make sure we... Alright, so derivative of the numerator multiplied by the denominator. Subtract the numerator, multiply that by the derivative of the denominator. All of this will then in turn get divided by the denominator squared. Cotangent, so if you square it, it's to the fourth now, and you square it, it's going to be to the 8th. Now notice I didn't touch the argument, I squared the whole denominator, so it went to cotangent to the 8th. All right, so these are a really good practice of still using our base rules, power, product, quotient, and chain, while then throwing into the mix how to use these. As I said, it becomes very important. Not that it's a huge component of the pre-calculus 12B, but you'll run into major difficulties if all of these differentiation rules are not in place when we roll into second semester and start doing what are called integrals and basically undoing these rules. So right now we're learning them this way. Next semester we need to know them both directions. So if you don't know it this way, you certainly are not going to know it in this direction. Okay, so let's look at a few more examples here just quickly. So this is my first one. F prime of x will be, so it's cosine u. Now it's addition, so it's just two separate terms. I don't need any other rule other than cos u is negative sine of u. I'm going to write it this way just in preparation for the derivative. So that's the same thing. Negative sine u. Multiply that by the derivative of this, which is a chain rule. 1/2 5x minus 1 to the negative 1/2. Multiply that by the derivative in the brackets. That would be the derivative of cosine square root 5x minus 1. Plus tangent u. Now notice where the exponent is. It's on the argument. It's not on the trig ratio. So the whole thing's not cubed. Just the x is cubed. So this is tangent u. Derivative of tangent u is secant squared of u multiplied by the derivative of u, your argument. That one's done. All right, got a couple more here, and then that should be enough to see how these things work. Okay, so this one, it is a quotient. So derivative of the numerator would be secant of u multiplied by the tangent of u multiplied by the derivative of u. There's derivative of the numerator. Multiply that by the denominator. Subtract the numerator. And now I need the derivative of the denominator, which is cotangent u. The derivative of cotangent u is negative cosecant squared of u. Multiply that by the derivative of u. Derivative of the numerator multiplied by the denominator. Subtract the numerator multiplied by the derivative of the denominator. All of that over the denominator squared. All right, I got one more here. I got a couple of chain rules because this one means the whole thing is squared when your exponent's there, and then this one's all underneath your square root sign. So let's differentiate this one. This would be, remember this means cosecant of radical x squared. So it's chain rule. 2. Leave your function as it sits. Take one off your exponent. Now differentiate what's in here. Negative cosecant u, cotangent of u, multiply that by the derivative of u. That's the derivative of this one. Subtract. Another chain rule. This whole thing would be to the half, so it would be 1/2 sine of 9x to the 6th. Take one off your exponent. Now I need the derivative of what's inside of these brackets. The derivative of sine u is negative cosine of u multiplied by the derivative of u, which would be 54x to the 5th. All right, so it's just a matter of using your trig rules that I identified in that chart as they kind of fall in place as you're doing your other differentiation rules, whether they be product rules, chain rules, quotient rules, whatever it may be. All right, that's all we have on derivatives of trig functions. So you'll have to add this to the list of things that you now are required to know. Again, these are not provided on any kind of a test or exam, so you need to know these rules. There will be some practice to follow, and there will be a formative to follow on this stuff as well. So best of luck, and as always, reach out if you have any questions or concerns. Thank you.